Today I'm going to interview Elizabeth Cochran, who is the Associate Professor of Geology at UCR. My first question is, how does the Richter scale measure the earthquakes?
So a Richter scale basically tells you approximately how large an earthquake is, and it's dependent on how far away you are from the earthquake and how much shaking you feel. But there's typically only one Richter magnitude for each earthquake that you measure.
What other instruments do you use for earthquakes?
So the types of instruments that we use seismometers. So these are basically a little mass on a spring, and when the ground shakes, the mass wants to stay still, and so you see the relative movement between the mass and basically the ground shaking. And then we can also use satellite data to look at how much the ground has moved during an earthquake.
Okay. My third question is, what is the Richter scale made with?
So the Richter scale was originally devised by someone just looking at a lot of earthquake data. So this guy Richter, Charles Richter, was here in Southern California, and what he wanted to do was figure out a scale where he could measure the teeny tiniest earthquakes along with the very large earthquakes. And so what he did was he defined the Richter scale by the smallest earthquake he could measure at the time at 100 kilometers away. And he called that a magnitude 0 earthquake. And then he made all of the other earthquakes relative to that initial earthquake.
Why are some earthquakes confined to small areas? Like I feel an earthquake in Riverside, but my grandfather in Sacramento can't feel it.
So the earthquake is, when you feel an earthquake, you're feeling the seismic waves. And so an earthquake starts and ruptures along a fault. So this fault breaks like this, and then it sends out these seismic waves. And just like when you drop a rock into a pond, the waves get smaller and smaller as you go farther away from where you dropped the rock. It's the same with the seismic waves. So if the earthquake's close to you and you feel it, your grandfather may not feel it because the waves have basically died out before they get to him.
Okay. When did scientists start studying earthquakes?
Well, they've been studying them for a really long time. They've studied them for probably 500 years or more in Japan, but sort of modern seismology, the modern study of earthquakes, started probably after the Lisbon earthquake in 1755.
What's the biggest earthquake you've ever been in?
Well, I was in the magnitude 7.1 hectomine earthquake. So this was in 1999, and at the time I lived up just north of Santa Barbara, and I could feel the waves all the way from that earthquake, which happened out in the Mojave Desert, so east of us here, and I could feel it all the way up several hundred kilometers away.
I was on a website, and it was talking about the earthquake myths that they had made, and these myths were very funny. They're like there's animals that are holding up the earth, and when they move, the earth shakes.
Yeah.
I never heard any of them. Have you you heard them when you're growing up? Or?
I heard them both. Some of them when I was growing up, but more of them since I became a seismologist. So one of the most well-known ones is the Japanese myth, where under the island of Japan there's a large catfish, and most of the time it sleeps, but when it wakes up and gets angry, it rattles around, and that's why there's earthquakes in Japan, or so they thought.
When there's an earthquake, why is there a fault along the earth?
So the faults are there because basically the earth is made up of very large plate tectonics. Have you heard of plate tectonics? So the outside of the earth has basically a bunch of really large plates riding on it. And so the continents, like the North American continent, is sitting on one of the plates, and then the Pacific Ocean is another plate. And they come together right here in California, and that's why we have so many earthquakes in California. So the faults are happening where these two plates come together, and you get the faults along where the plates come. All right. So this is showing just the output from the sensor, and I can also show you. So this is a map of the globe, obviously, and the purple lines are these plate boundaries that I was telling you about. So this whole thing here is a big tectonic plate, and then there's another one up here. And then you'll notice that all the earthquakes, or most of the earthquakes, are happening on or near these plate boundaries. So the red dots are all earthquakes. The blue dot, so this is a historic earthquake, and that's the Lisbon earthquake. And so if we just look here we are in California, you can see we're at a plate boundary between the North American plate here and the Pacific plate here. So, so this is kind of a fun project because basically we can record earthquakes. The vertical and the horizontal axes of the sensor, and then I'm going to hit the sensor, and you'll see that this is from me stepping on the sensor, basically. So these are sensitive enough that you can pick up sort of medium to large earthquakes. Any earthquake that you could feel, you could basically pick up with one of these sensors. And so the idea is to get lots of recordings of earthquakes using these things.
So the one up there, is that the one in the red, is that one gonna record the earthquakes that actually happen?
Yeah, so this is significance, which is basically these three things added up, and it doesn't start until after it's been running for at least a minute or so, and there you go, now it's starting. So if I do the same thing, if I hit the sensor now, so you'll notice that the significance is very high, so that means that we have some large motion, and so then if that was a real earthquake, it would send data back to our server.
Okay. That's cool.
Yeah.
Thank you for having this interview with me, and I hope we get to talk again soon. I'd like to learn more about earthquakes.